في ساحة للعلم كنا نلتقي والحب والإخلاص.
Assalamu alaikum and welcome to the Qurtuba Online Math Show presented by me, Mr. K from the QOA Institute in association with Hilaal TV. Guys, bumper episodes. I hope you are checking out the episodes, right? If you've missed any of them, go to the Hilaal TV YouTube channel. All the episodes are put there on our previous episodes. We finished the whole, just to do a quick recap as to where we are. Remember, we're doing 16 episodes, guys, right? Grade 12s, we are doing 16 episodes. And these 16 episodes, I'm going to finish the whole of paper 1, the whole of paper 2. Basically, we're doing the whole year's work in 16 episodes, each of 1.5 hours duration. So we're looking at 24 hours. So what are we doing in 24 hours? We are finishing the entire grade 12 syllabus in 24 hours. Okay. Yeah. Big, it's a tall order. It's a tall order, but it can be done. And we're going to show it to you here on Hilaal TV, how it's done. So you tuned into the best TV station in South Africa. Guys, let's do a quick recap. What have we done in calculus? Right, remember in the previous episode, I gave you the whole checklist for calculus. We did first principles, we did derivative, we did the whole and all the different types of differentiation. Okay, we're now moving on to topic number 4 in calculus. Right, after this is only 2 more topics and we're done with calculus. 40 to 50 marks in paper 1. Equations of tangents to a functions at a point. The equations of tangents are very important topic, guys. Very important topic. The equations of tangents to a function at a point. Now, you know a tangent. That's why I highlighted it here. I squared it off. A tangent is a straight line. And we want to find, and we know that the equation of a straight line is given by y is equal to mx plus c. Okay, and it's part of calculus, so you know we're going to be using derivative. You know we're going to be using differentiation. Why and where? Derivative differentiation to find the general gradient at a point. So basically, you might be given a parabola and you might be given a straight line graph. They'll give you the equation of the parabola and you need to find the equation of the straight line. That is a tangent. What is the meaning of a tangent? A tangent means that a line which touches the graph at one point, right? It touches at one point. So that is a tangent. Who knows what is the meaning or what do you call a line that cuts at 2 points? Right? This is a tangent. Cutting at 2 points, who knows? It's called a secant. It's called a secant. A secant touches at 2 points. A tangent touches at 1 point. Okay, so that's just for some further insight as to the topics, right, about what we're going to be talking about. So let's start off with a question, guys. Let's start off with a question. Let's see what would a question like this. Now, there are different types under equations of tangents. Under the equations of tangents, there's probably about 3 or 4 different types. We're going to do each of these different variations of the type of questions that you would see, that you could possibly see in your final exam. And these are the most popular ones. If you know these, there's nothing that could beat you in your exam. All right, let's start. So, let's just say the question looks like this in the exam. And it says, if f of x is equal to, let's make one up. Let's make one up. Let's say 4x squared minus 3x. Find the equation of the tangent to f of x at the point x equal minus 2. Right? For 5 marks. For 5 marks, this is the question. Take it down. Those of you who know how to do it, you have seen it in school, you have seen it in past papers, you can start working it out already. Don't wait for me, right? You start working it out. You can just use my calculations as a memorandum for yourself. Okay, answer. Now remember, these shows are all now, obviously, they are being aired. We are going to be having a live show. So please just check on Hilaal TV, check on the website, when is the live show going to be aired. We're still busy working out those, and where you guys will be able to phone in and call in and send questions to a WhatsApp number, and I'll be able. Now, obviously, if there are 6 million viewers, I'm not going to be able to answer everybody's question. We'll take selected questions from people, and we will be able to answer all of them. And obviously, we're going to give shout outs to people that we know, or people that want us to give a shout out. There'll be a rolling lower third on the TV. Shout out to all the learners from all the different areas in South Africa, wherever we have engaged. Right? Remember, we have engaged with over 1 million learners across South Africa over the past 20 years. Over 1 million learners in almost every town in this country. Right? We've done Polokwane, we've done Limpopo, we've done Shoshanguve, Khayelitsha, Mitchell's Plain, Grassy Park, Mandeni, Ladysmith, right? We can't forget Ladysmith and all the different programs that we've done there in Ladysmith, Johannesburg, Rustenburg, every town in this country. So guys, we want it as a national initiative, so everybody follows the same train of thought. Okay, so big shout out to everybody. Hi guys, those of you who know me, thumbs up. Right, welcome to the show. Let's start. If f of x is equal to 4x squared minus 3x, find the equation of the tangent to f of x at x equal to. By now you done already? Let's check. The first thing we need to do, we need a point. Remember, for y is equal to mx plus c, for y is equal to mx plus c, I need a point. I need x and y, and I need a gradient. These are the two items that I require. What do I require, guys? What do I require? I need a point. I only got x minus 2. I don't have the y, so I need to find the y first. And then I need to find the gradient, and that's where we're going to be using our friend, Mr. Derivative. Okay. So let's start. The first thing I'm going to do, I got the x. I need y. Remember, that's y. So we're going to go now f of minus 2. Right? Plug and play. We're going to substitute it directly into here for every x. So 4 into minus 2 squared minus 3 into minus 2. So this is going to equal to 4 into negative 2 squared is 4 plus 6. 4 times 4 is 16 plus 6, which is equal to 22. Right, that means my point now, guys. What is my point? Negative 2 and 22. Let's write it here. Right, let's write it here. 22. So we're going to put the point here. What's it? Minus 2 and 22. That's y. That's my x. That's my y. So I got this. So we scratch this out. So I'm done with that. What am I short of? My gradient. And that's where I need to use the derivative. Right? So we need the m. So we're first going to find the derivative of f. So we're going to find our general gradient. Watch here. You can write this in your exam in pencil on the side. Put there general gradient. What's your general grade? I just put grad, right? I just put grad, general gradient. It's derivative, so f dash x. Now we are applying the power rule. Remember, f dash x, we are using the derivative. We are now applying the power rule. So let's apply the power rule. 2 times 4 is 8. X to the power 2 minus 1 is 1. 1 times minus 3 is minus 3. X to the power 0 is 1. So there we go. Minus 8x, 8x minus 3. That's f there. That's your general gradient at any point on this parabola. At any point on this parabola, it's given by 8x minus 3. Now, at the point x equal minus 2, you're going to say, so therefore the m of your graph, the m of your tangent, the m of your tangent is going to be f dash minus 2. So we're going to put that into f dash x, f prime x. So 8 into minus 2 minus 3. That would give me minus 16 minus 3 is minus 19. And there we go. We now got the m. We got the m. So we got the point. We got the gradient. We got the point and we got the gradient. The m is equal to minus 19. So now what do we need to do? Y is equal to mx plus c. Am I right? Of course. So now, there's it. Logical sequence, logical process. Step number 1, get the x and the y. So here's it. Let's just write it out again for you. Step number 1, you get your y value. Step number 2, that's step number 1. Step number 2, you find your general gradient, derivative. Step number 3, f dash minus 2. So we got negative 19. So now you know 1, 2, 3. It's done in 4 parts. There's one more part. Obviously, which is that last part? Y is equal to mx plus c. Because we got a point and we got the gradient. So let's go. So we've got, minus 2 and 22. M is equal to minus 19. Right? I'm just going to clear that. So now we're going to go for the equation of your tangent. For the equation of your tangent, this is step number 4. We're going to use y minus y1 equals m into x minus x1. You've seen this formula for y is equal to mx plus c from analytics, right? Which is paper 2. And remember, this is also coming up in our future episodes. So please stay tuned to the channel, right? What was our point? Minus 2 and 22. That was our x, that was our y. What was the m of our graph? 19. Now you can use, many of you say, no, I like to use y is equal to mx plus c. Then you find it's a long process. I'm just giving you a better formula from analytics to use. So now we just substitute. So here we go. Y minus y1 minus 22 is equal to m, which is 19, into x minus 2 plus 2. Now we just remove the brackets. Y minus 22 is equal to 19x plus 19 times 2, 38. That's a 22, right? Doesn't look like 22. So y is equal to 19x plus 38. Minus 22 will come on that side as plus 22. So here's your final answer. 19x, 38 plus 22, 38, 40, and that would give me 60. Plus 60. Plus 60. And there we go. That is your final answer. That is the equation of your tangent. This was step number 4. So how many parts? 4 parts. What was the first step? Get x and y. Step number 2, derivative. Step number 3, substitute x into your derivative to get the m value. Step number 4, y is equal to mx plus c, or y minus y1 equals m into x minus x1. Whew! There we go. There we go. Take this down. Did you get it right? I hope you did. I hope you're satisfied with yourself. Right? So, okay. But this was basic. This was level 1. Yeah, you're smiling. This is level 1. We're then going to go to level 2 and level 3. Let's see. Let's see now. Here you are required to find the equation. What if the equation was given? And you needed to work back to find the equation of your original equation. For 6 marks. For 6 marks. Let's go. You ready? Take a deep breath. We're about to go underwater. Right. This is type 2. Now I tell you, watch this question. And I know you're going to smile. You've seen it in the exam before, right? Whoa, what happened there? Even my jacket is making a mark on the screen. Right, so we go. If f of x is equal to, let's say, x cubed plus ax squared plus bx minus 5 has a tangent. Now we're telling you it has a tangent given by g of x is equal to 2x minus 4 at the point x equal minus 1. Find A and B for 6 marks. I know you're smiling. I know you're smiling. Grade 12s, I know you're smiling. You've seen this before. And normally at school, you just saw a whole lot of handwriting on the board and you didn't even know what. I'm going to give you such a beautiful work of art today. I'm going to give you a template that you're going to use. Clean, neatly cut template. All you have to do is copy and paste into the template and you're going to get your solution, right? Find A and B. Find the values of A and B for 6 marks. Are you ready for it? South Africa, the world, viewers of Hilaal TV, DSTV channel 347, are you ready for this? Let's go. Take out your calculators. Answer. Again, I'm telling you, as I say in every episode, I am not doing rough calculation on the board. Exactly the way I answer it here, you can answer it in your final exam. Step. Right, let's go. First one. We know that this graph, that's a straight line. So these two graphs, they touch each other. Right? The two graphs touch each other. So the one is a cubic function. It's a wave. That is a wave. And we know this is a straight line. And they meet at the point x equal minus 1. What do we know? And I want you to listen carefully. What do we know about when two graphs touch? And this is one of the most crucial and critical components of calculus. I want you to understand something. When two graphs touch, yes, everybody will say the two graphs are equal. Yes. Obviously, graph F is equal to graph G. No problem. You are right. You are 100% right. The two graphs are equal. Why? They touch at the same point. They have the same x and the same y. But not only are the two functions equal, not only are the two graphs equal, their gradients are also equal. Their gradients are also equal. I'm repeating that. I want you to remember that. The gradients are also equal. So what can I say? So if we want to make simultaneous, remember we're looking for A and B, so we want simultaneous equations. So we got our function equation. There's our function equation. Graph F is equal to G. And our gradient equation, we know, I said that the gradients are equal. So that means F dash X. The derivative, the gradient on F is also equal to the gradient of your straight line. And your gradient of your straight line is equal to M. Now, if you can remember that, boom, Bob's your uncle. You're done. Because equation 1, equation 2. And you just solve simultaneously. And that's exactly what we are about to do. So remember this, guys. Right? Remember that. Where two graphs meet, function equal function, gradient equal gradient. So let's go. Right? You've taken this down. Oh my word. Let's go back. There we go. So now we want to erase that. So let's just go there. Let's take all that out. Right? And so we got function equal function, gradient equal gradient. Let's take that out. All right. Let's go. Let's work this out. Have you started working on it already? I hope you have. I hope you have. So I'm going to give you the template. As I promised you, I'm going to give you a template. You want to do it in red? Yeah, let's do it in red. Let's keep red. All right. So this is the way you're going to answer it in the exam. You're going to say function equal function. Then you're going to say gradient equal gradient. Equation number 1, equation number 2. Neat, clean. Let's go. Function equal function. That means that graph must equal to that graph. That function equal to that function. So we got x cubed. Let's write it here. X cubed plus ax squared plus bx minus 5 is equal to 2x minus 4 at the point of contact. At the point of contact, the two graphs are equal. Right. Then we've got gradient equal gradient. Then we've got gradient equal gradient. So let's go back. Let's go input. So what did I say about gradient equal gradient? The derivative f dash x, the gradient of the one graph is equal to the gradient of the other graph. So what is f dash x? The power rule. 3x squared. Remember, power times coefficient minus 1 from the power, plus 2 times 1 is 2ax, plus 1 times b is b, the 5 will fall away, is equal to the m, the gradient of this graph, which is 2. Not equal to 0. They don't say for minimum or maximum. That's the only time you equate your derivative to 0. Right? Here we're saying gradient equal gradient. And we've got x, guys. What is x? minus 1. So what are we going to do with the minus 1? We're going to take the minus 1 and we're going to substitute it for every x there. We're going to take the minus 1, we're going to substitute it for every x there, and we're going to get our answer. We're going to get two equations and we're going to solve simultaneously. So let's do it together. So we're going to take the minus 1, the negative 1, we're going to plug it here for every x. So what do I have? Minus 1 cubed plus a into minus 1 squared plus b into minus 1 minus 5 is equal to 2 into minus 1 minus 4. Right. Now let's, the negative 1 cubed is minus 1. That's plus a minus b minus 5 is equal to minus 2 minus 4. So a minus b minus 1 minus 5 is minus 6. So you're going to have minus 2 minus 4 is minus 6 on that side. You got minus 6 on this side. It's going to come on this side here as plus 6. So you got a minus b is equal to 0. It's just purely coincidental. It's purely coincidental. So basically a is equal to b. Right? A is equal to b. Right? If I took that b on the other side, and that's equation number 1. Purely coincidental. Let's just check our algebra again. Minus, negative, negative, there, that. Minus 1 plus a minus b minus 5 minus 2 minus 4. That's right. A minus b, there we go. Minus 1 minus 5 minus 6. Goes on that side, plus 6. Minus 2 minus 4 minus 6. Minus 6 plus 6, 0. A minus b equals 0. A equal b. Correct. Correct. Let's now put the minus 1 in here. 3 into minus 1 squared plus 2a into minus 1 plus b is equal to 2. So this would give me 3 minus 2a plus b is equal to 2. Minus 2a plus b is equal to 2 minus 3 is minus 1. So we got b is equal to minus 1 plus 2a. Now we know a is equal to b. So I can now substitute this into here. So instead of b, I can put a. A is equal to minus 1 plus 2a. So 1a minus 2a is minus 1a is equal to minus 1. A is equal to 1. And a equals b, so b also equals to 1. And there we go. A is equal to 1, b is equal to 1. Right? It just worked out. It just worked out. So here's the template. Function equal function, gradient equal gradient. The first equation in terms of a and b, that's equation number 1. The second equation in terms of a and b, so it's either that or this, they're the same. And you just work a and b out simultaneously. And we're done. We are absolutely done. Now let's do one with regard to minimum and maximum, right? Where they tell you has a local minimum or it tells you has a local maximum. Let's see how we do that one. This was type number 2. We're going on to the last type. This is the last type of equations of tangents, right? Or working with A's and B's in your equation. Then we're going on to the cubic graph. Okay, let's see. We're going to erase this. Let's just find out how many minutes do we have left. Okay, guys, we've only got 1 minute left before the end of this segment. I hope you've taken all this down. I'm going to put the last question down for you. And let's see whether you can work this one out during the break, during the ad break. So let's put this one down. The function f of x equals x cubed plus ax squared plus bx minus 4 has a local minimum. At the point P, 2 and 12. Right? At the point P, 2 and 12, find the values of A and B. Find the values of A and B. Guys, we're going to cut for break now. It's worth 6 marks. It's worth 6 marks. You need to find the original equation of graph F. I hope you've enjoyed this segment, and I'll see you guys. Work out this one here, and I'll do the memo as soon as we get back from break. Assalamu alaikum and welcome back to our second segment of the Qurtuba Online Show. Right, we're doing calculus. I'm your host and presenter, Mr. K from the QOA Institute in association with Qurtuba Online and Hilaal TV. Guys, grade 12s, parents, learners, teachers, I hope you are enjoying the show. Give your feedback. Send your feedback to Hilaal TV. You can phone them, check them up on the website. If you're enjoying the show, you'd like more of these shows to go on for the rest of the year. If you'd like the grade 11s and you would want grade 10 mathematics also on your show, speak to the people. Remember, we're just a phone call away. Phone Hilaal TV, speak to them. Let us know what your thoughts. Like I said, trolls, if you are a troll, if you're trolling the show, stay away, go and enjoy something, enjoy football, enjoy something else. This year is only for those who want to master mathematics. Okay guys, let's get back to the show. I left you with this question before the break. Let's go and let's sort this out. Okay, so this was your question in your exam, in your answer. Now, in the previous one, we did function equal function, gradient equal gradient. That's what we did in the previous one. Here they say local minimum or local maximum. So I want you to remember something. So here's a small rule. Whenever they use the word local minimum or local maximum, I want you to remember this, that your derivative must always equal to 0. Why? Because if you have a graph like this, that's a cubic graph, that's your maximum, that's your minimum. A straight line has got 0 gradient. A straight line has got, so at minimum or maximum, your derivative. So whenever in mathematics they use the word minimum or maximum, find the minimum value, find the maximum value. Always derivative equal to 0. Remember that. Remember that. Keep that at the back of your mind. Make a note on your page, circle it, highlight it, put butterflies, stars, clouds, whatever you do. Just remember it. Okay, so let's start. So now we're going to need a function equation. We need a function equation and we need a gradient or a derivative equation. And that's going to be our two simultaneous equations. And you can do this in the exam. So your function equation, we got this point P, 2 and 12. We substitute it directly into here for x and y. So let's go. My function equation, 12, that's your y. 12. Is equal to x. What's x? 2. So it's 2 cubed plus a into 2 squared. For every x we're substituting 2. Minus 4. So what would this be? 12 is equal to 2 to the power 3 is 8 plus 4a plus 2b minus 4. So 12 equals 4a plus 2b. There we go. 8 minus 4 is 4. 12 minus 4 is 8. So 4a plus 2b is equal to 12 minus 4 is 8. Let's divide everything by 2. So 2a plus b is equal to 4. And that's equation number 1. So we got the first equation in terms of a and b. Let's get a derivative equation now, guys. Let's get a derivative. So now we're going to say f dash x is equal to 0 for minimum or maximum. What's your derivative here? You're going to have 3x squared plus 2ax plus b is equal to 0. The 4 will fall away. You know it by now. Let's now put in, we got the point at x equal to, so 3 into 2 squared plus 2a into 2 plus b equals 0. So 4 times 3 is 12 plus 4a, 2a times 2 is 4a plus b equals 0. 4a plus b equals minus 12. That's equation number 2. So we got 2a plus b equals 4. We got 4a plus b is equal to minus 12. Let's work it out simultaneously. Let's put this 2a plus b. 2a plus b equals 4. That's equation number 1. And let's solve simultaneously. What am I going to do to cancel the b's? Am I going to add the two equations, subtract, multiply, or divide? I'm going to subtract. Why am I going to subtract? To get rid of the b's. So I'm going to subtract the 2. Equation number 2 minus equation number 1. So that's going to be minus. That's going to be minus. That's going to be minus. So 4a minus 2a is 2a plus b minus b is 0 is equal to minus 12 minus 4 is minus 16. So what is a equal to? Minus 16 divided by 2. A is equal to minus 8. A is equal to minus 8. There we go. We've got A. Find the values of A and B. We got A. A is minus 8. Let's now get B. We know B is equal to 4 minus 2A. B equals 4 minus 2. We got A as minus 8. Therefore, I'm just moving over to the side. B is equal to negative 2 times negative 8 is 16. 16 plus 4. B is equal to 20. There we go. A is equal to -8, B is equal to 20. And I hope you've taken all this down. Makes perfect sense. It's a wonderful piece of art, right? So we got the function equation, we got the derivative equation. Function equation, plug and play. You just substitute x and y. Derivative equation, you make f dash x equal to 0. Why 0? For minimum or for maximum. And there we go. Two equations. Equation number 1. There we go. And equation number 2. There we go. We solve simultaneously and we get our values for A and B. Okay, so that brings us to the end of equations of tangents. We're now about to go onto the cubic graph, how to sketch the graph and how to determine equations of the graph. All right, so that's the next point. Very important. Very, very, very important. Remember, this is about 12. That's going to be about 12 marks in your final exam. So let's go for it. You've taken this down. Let's delete that. Let's put there the cubic graph. Now I'm going to go through some basics with you before we start the cubic graph. So before we start the graph, remember, what do we need to know about the graph? Number 1, we need to know how to sketch a graph. Right? Number 2, if a graph is given, we need to know how to find its equation. So you could see that or you could see that. Find the equation of the graph. We need to tell you, you need to know where is the graph increasing or where is the graph decreasing. You need to know where the graph is concave up. You've heard these words, concave up, or where is the graph concave down. You need to know how to give the domain and the range of the graph, and you also need to know how to work out point of inflection. These are all the items that you need to know. And you need to know where is f of x greater than 0, less than 0, where is f of x greater than g of x, all those type of questions. So here we go. There's 8 major components here. 8 major components. We're going to start with the first one here. How to sketch the graph. Now, before we go into sketching the graph, what do you need? Okay, let me show you. Okay, let's take a graph. Let's take a graph. F of x is equal to x cubed plus x squared minus 5x plus 3. They love this question. This question, that's why I memorized this question. I mean, most of it, you don't see me working with any notes here. I know, because I've just memorized all the types of the most commonly asked, humanly possible, because these are templates. Once you know the template, no matter what they give you, you apply the same rule, you're going to get the same result. Okay, let's go. So we've got f of x is equal to x cubed plus x squared minus 5x plus 3. We need to sketch the graph. So forget about everything else here. We're only focusing on the first part here, which is to sketch the graph. Sketch, so show all calculations for 12 marks. Sketch it fully, right? Sketch fully. Now, let's do some background information about this graphs before we actually start with our calculation. Right, let's do it here on the side. Let's do it on the side. Now, you know, a cubic graph, power 3, right, will have 3x intercepts. So if it will have a maximum of 3. It could have 3, it could have 2, it could have 1. Let me just show you what the end result is going to be. If this value here is 0, if it's a positive graph with 3x intercepts, then obviously you know what your graph is going to look like. 1, 2, 3. That's a positive graph. A negative graph with 3x intercepts is going to look like that. Let's look at it with 2x intercepts. How would the graph look? Right. A positive graph would look like that. And a negative graph would look like that. A positive graph, increasing function. Negative graph, decreasing function. Number 3, with 1x intercept. Oopsie. With 1x intercept, how will the positive graph look? I'm just going to draw it here on the side. It will look like that. And then the negative graph, where are we going to draw it? You're going to do it here. Let's do it here. Negative graph would look like that. Okay, so there we go. 3x intercepts, 2x intercepts, 1, 2, 1, 2. 1x intercept just there and just there. But all of them have got 2 turning points. Okay, so I'm just showing you what your end graph is going to look like. We don't know yet which of these this graph is going to look like. Okay, so let's get started. What's our checklist for sketching a graph? What is our what is our checklist of sketching the graph? Right, in order to sketch the graph, what do we need to know? We need the y-intercept. So let's go back. We need the y-intercept. That's where the graph is going to cut on your y-axis. You're going to need x-intercepts. Then we're going to need turning points. And then we're going to need the point of inflection. I'll explain to you all of this as we go along. So we need y-intercept, x-intercept, 2 sets of turning points, and 1 point of inflection. What did the graph look like? F of x was equal to x cubed plus x squared minus 5x plus 3. Right. Question, answer. Let's start answering it here. How do we get our y-intercept? Right? You all know to get your y-intercept, you're going to say let x equal to 0. So let x equal to 0. So if x is equal to 0, y will equal to, so that's 0, 0, 0. What's y? Y is equal to 3. Right? So there we go. We got our y-intercept. Done. Let x equal to 0. We get our y-intercept. How do we get our x-intercepts? We use the factor and remainder theorem. So we're going to try for a number to be a factor, it must have 0 as a remainder. I'm going to repeat that. For a number to be a factor, it must have 0 as a remainder. Let's take an example. Take the number 6. The number 2 goes into 6 how many times? 3 times. What's the remainder? 0. Therefore, 2 is a factor, 3 is a factor. So what we're going to do to find the x-intercepts, we're going to use the factor and remainder theorem. We're going to try f of 1. Right? You're going to try 1. And if you must get 0 as a remainder. If 1 doesn't work, then you'll try minus 1. If minus 1 doesn't work, try 2. If 2 doesn't work, try minus 2. If minus 2 doesn't work, try a half and try minus a half. These are the most commonly used ones here for the factor and remainder theorem. Right, so let's try f of 1. For every x, we're going to put 1. 1 cubed plus 1 squared minus 5 into 1 plus 3. This is equal to 1 cubed is 1 plus 1 minus 5 plus 3. Ding, 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 ding. 1 plus 1 is 2. 2 plus 3 is 5. 5 minus 5 is 0. So therefore, yay, we got 0 as a remainder. That means x minus 1 or x equal 1 is my first. So basically your factor is x minus 1 is a factor. Why x minus 1? Because x minus 1 equal to 0, x will equal to 1. And there we go. That is your first factor. That's your first root. That is your first x-intercept where that graph is going to cut through. You're now short of 2 or 3. We don't know exactly. We're short of the other x-intercepts. So, step number 1, let x equal to 0. Step number 2, the factor and remainder theorem. Step number 3, we use what we call synthetic division. Don't use long division. Use the shortcut, synthetic division. So we take this one outside. We take this one that we found. We put it outside. We put all our coefficients, 1, 1, minus 5, 3. It must be in descending order. 1, 1, minus 5, and 3. 1x cubed plus 1x squared minus 5x plus 3. Right. We bring this first, we take this one up here. We bring it up there. We take this one, we bring it there. We take it to the top. When you come across, we're now going to multiply. So when you come across, you multiply. Whatever answer you get, you add to the next term. And we repeat the process. So here's the process on the side, guys. Here's the process on the side. Multiply and then add. That's arrows. Multiply and add. Multiply and add. So this one, where did this one come from? Let's draw it there. There's the one there. There's the one there. This 1, 1 minus 5, 3 came from your original. This one you picked up. Now we're going across. We multiply. Then we add. So 1 times 1 is 1. Right? We're multiplying. Remember, do it mentally. 1 times 1 is 1. 1 plus 1 is 2. Now we repeat the process. 2 times 1 is 2. 2 minus 5 is minus 3. Minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. You must get 0 at the back. So you had, this was x cubed, right? This was x cubed. You took out 1. So this must be x squared. So here's your answer here on the top. The quotient here on the top, here we go. 1x squared plus 2x minus 3 equal to 0. And let's factorize that. That is a trinomial. So we're going to have x and x, 3 and 1, plus and minus. So x is equal to minus 3 or x is equal to 1. And we got x is equal to 1 there also. So that means this graph has only two x-intercepts. Minus 3 and 1. This could have been a different number. That could have been a different number. That could have been a different number. That means this graph would have had 3 x-intercepts. In this case here, this graph has only got 2 x-intercepts. So your y-intercept, y is equal to 3. Your x-intercepts, x is equal to minus 3 or x is equal to 1. Now comes our turning point. So let x equal to 0, solve for y. The factor and remainder theorem. This here is the factor and remainder theorem. To find your first factor. Right, so we tried f of 1, we got 0, we got our first factor. Then we do what we call synthetic division. And synthetic division, we put our coefficients inside. There's it, 1, 1, minus 5, 3. You take your first factor, you put it out. You take this one, you bring it up. We multiply when we go across. We multiply. So let's go back to our pen. We multiply. Whatever answer we get, we add. So 1 times 1. 1 times 1 is 1. 1 plus 1 is 2. Now we repeat. 2 times 1 is 2. 2 minus 5 is minus 3. Minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. And there's your answer there on the top. 1x squared plus 2x minus 3. You factorize that and you get your other two factors. So we got our y-intercept, we got our two x-intercepts. Right, what am I short of, guys? Turning point, and that's where we use our friend Mr. Derivative. We use Mr. Derivative there for the turning points, and then our point of inflection. And another word for point of inflection is the point of concavity. That's the change over of the graph from either acceleration to deceleration or deceleration to acceleration. Right? So that's your point of inflection. Now we're going into our turning point. So we got this. Y is equal to, remember, write all this down. I hope you took a screenshot of it even with your phone. Y is equal to 3. X is equal to minus 3, x is equal to 1. Now we need our turning points. So let's go to our turning points. So now we go again. F of x is equal to x cubed plus x squared minus 5x plus 3. Right. So now we need our turning points. TPs. Another word they could call it is stationary points. So we call it SPs. Right? Another word for turning point is stationary point. Why do they call it stationary point? Why do they call it a stationary point? Because if you have a graph like this, acceleration, at that point, it stops. Nothing happens there. Stationary. Deceleration, or increasing, stop. Decreasing, stop. Increasing. So at your two turning points, it's called stationary because your derivative is equal to 0. So your stationary points derivative f dash x is equal to, let's do the power rule here. Let's just find out how many minutes we've got here. We've got 4 minutes left for the segment. So 3 times 1, that's 3x squared plus 2x. 2 times 1 is 2x minus 5. For minimum or maximum? What is your derivative equal to? 0. So we equate that to 0. Let's factorize this. 3x and x, 3x squared, 5 and 1. We want plus, so that's plus, that's minus. So 3x plus 5 is equal to 0, or x minus 1 is equal to 0. 3x is equal to minus 5. X is equal to minus 5 over 3, or x is equal to 1. These are our two x values of our turning point. We now need our y values. So your one turning point is minus 5 over 3. We don't have its y. Your other one is at 1 and we don't have its y. Now we need to find the y. So you take this and you put it back into the original. Guys, what do we do with this? We take this and we plug it not back into here. You're going to get 0 because it's a root. We're going to plug it back into the original. So we're going to go f of minus 5 over 3 is equal to, now you're going to plug minus 5 over 3 cubed plus minus 5 over 3 squared minus 5 into minus 5 over 3 plus 3. You can work it out on your calculators. You're going to get 9,48. So we're going to put 9,48 there. And then f of 1, we're going to do f of 1. And we know f of 1 is 0. We remember we did it? F of 1 is 0. And there we go. Those are our turning points. Those are our 2 turning points. We're not yet done. We got one more component to do, which is the point of inflection. Right. Now you know how to do the point of inflection, grade 12. Second derivative. Do your point of inflection. Do your point of inflection. We're going to cut for break. When we come from break, I'm going to work out your point of inflection. We're going to sketch the graph. Then we're going to do the reverse. If the graphs are given, how do you find equations? Okay. Guys, I hope you guys enjoyed the segment. That's where we're going to stop for now. Right. Nice tea break or some oxygen break. Take a little bit of a breather. When we come back, we'll complete. But for the rest of you, grade 12, I want you to work out the point of inflection. Second derivative for this graph. Okay, guys, I'll see you guys after the break. Assalamu alaikum. Assalamu alaikum and hello everybody. Welcome back to the last segment of today's show. We are doing calculus, the cubic graph. I asked you before break to do the point of inflection, and we're now going to be sketching the graph. We're going to be sketching the graph, and then we're going to be doing the reverse of the graph. If you're given a graph and how to find its equation. Then we're going to talk about where is the graph increasing, decreasing, point of inflection, concavity, where is it concave up and where is it concave down. Okay, guys, I hope you guys are enjoying the show. I'm your host and presenter, Mr. K from the QOA Institute, in association with Qurtuba Online Academy and Hilaal TV, your best station on TV at the moment. Guys, stay tuned. We've got a bumper session planned for you now. I hope you worked out the point of inflection. This is what we did before the break. Let's now go and find the point of inflection. Now, as you all know, the point of inflection is your second derivative. So we found our turning points. These were our coordinates for our turning points. We're now going to be working out what is the point of inflection. So write there point of inflection, because that's what we're going to be now calculating. Right? We're now going to be calculating the point of inflection. And let's go. Right, so that's all out, that's out, that's out, and that's out. Let's now go and calculate the point of inflection. So now we found the turning points. We're now going to be doing the point. When I write POI, what am I referring to? The point of inflection. And this is the time where we're going to be using the second derivative. This is the only time in calculus you'll be using the second derivative, the derivative of the derivative. Right? The power rule on the power rule, or of the power rule. So this was your first derivative. This was your first derivative. So f double dash x, your second derivative. Again, apply the power rule to your derivative. 2 times 3, 6x plus 2 is equal to 0. 6x is equal to minus 2. We're solving for x. X is minus 2 over 6. X is equal to minus 1 over 3. 2 into 2 once, 2 into 6 3 times. Now we take this minus a third and we plug it back into the original, and you're going to get 4,74. And that is your point of inflection. You make your point of inflection, you're equal to 0, you solve for x, you take x, you sub it back into the original in order to get the y value. That's the x value of your point of inflection. That is your y value of your point of inflection. That is also called the point of concavity. This will tell you at what point, at what value of x, at what value of x will your graph either be concave up or it will be concave down. Alright, but we'll get to that when I do the explanation. Remember, the question was to sketch the graph. So let's go and sketch the graph. You've got all the coordinates. Alright, you got your y-intercept, you got your x-intercept, you got your coordinates of your 2 turning points, you've got your point of inflection. We've got all the necessary ingredients to now go and plot our graph. So let's go and sketch our graph. Let's sketch our graph. Let's say, what color do we have here? We got black. Okay, so let's draw the graph in black. So let's go there. There we go. What was our x values, guys? X was equal to 1. X was equal to 1. Or x was equal to -3. -1, -2, -3. Right, those were our, remember this graph only had 2 x-intercepts. My y-intercept was 3. 1, 2, 3. My y-intercept was 3. What was my turning point? So I got my y-intercept, I got my 2 x-intercepts. My turning points was at 1 and 0. Remember my turning points when we calculated our turning points? What was our turning point? 1 and 0. And then the other one was -5/3 and 9,48. Remember, those were our 2 turning points. So you put a dotted line through the x value of your turning point here. Now -5 so there's it, 1 and 0. That's your 1 turning point. Your other turning point is -5/3. Now -5/3 as a decimal is -1,66666, which is 1,67, and then 9,48, right? So we're going to go -1,67, -1, -2, -1,5. I would say -1,66666 is somewhere there. That's -1,67, and then 9,48 is somewhere there on the top. So that's -5/3 and 9,48. There we go. That's your 1 turning point. It was a positive graph. Remember f of x. Remember x cubed was positive. Therefore, it goes from the bottom up. So now we go here from the bottom up. Watch here. We start at negative infinity. Increasing, 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 increasing. Stop. Turning point. We come down. Decreasing, decreasing. It cuts on your y-axis. Remember, that's your y-axis. This is your x-axis. This is 0. We're coming down. Decreasing, decreasing. It's supposed to cut through here, but it's also your turning point. So it changes direction there, and we can call that graph F. And there we go. That's your graph. That's your graph. Fully sketched. Our point of inflection. What was our point of inflection? -1/3, ne? It was -1/3 and 4,74. So let's go back. Where's your point of inflection? So let's do it in a different color, your POI. You must show it on your graph, guys. You might ask yourself, do I need to show the point of inflection on the graph? The answer obviously is yes. So -1/3, that's -1. That's -2, that's 0. -1/3 is somewhere there, and there we go. So that's your point of inflection, your point of inflection. And what was that? -1/3 and 9,48. And there we go. Your graph is fully sketched, and you'll get 12 marks with the calculation and sketching the graph. Now remember something, guys. There's so much. As you can see in our 6th episode, I think this is our control room. This is our 6th episode now. Right, correct. This is our 6th episode. Now in these 6 episodes, can you see the volume of work that we've covered? Now, if you can understand the volume of work that we've covered in 6 episodes, and we still got another 10 to go with another 2 live episodes to finish everything, can you see the Everest of work that needs to be understood in order for you to master? And you only got 3 hours in your exam. Only 3 hours in your final exam to apply all this knowledge that I'm teaching you, item for item, topic for topic, in order for you to master that exam. So it's no joke. You got to prepare. Blood, sweat, and tears. Like if you think that, hey, you know what, it's hard, it's difficult. Can you imagine me? I'm standing here, I'm talking to 5 cameras here, alone. There's nobody in the room. And I got to make sure that I get it right the first time. And we are in here, in studio, from 9 in the morning till 4 in the afternoon. It's no joke. People are sweating, blood, sweat, and tears to make sure that you pass. Now we can give 200% of our effort. Guys, meet us halfway. Just put in 100% effort in order to get your distinction. It's for you, it's not for me. You're going to go and do engineering. You're going to go and do health sciences. You're going to become architects, doctors, lawyers, travel. Whatever you're going to, whichever career path you're going to choose, it's up to you. You make your own future. Okay. Right, so let's go. Okay, control room, we're all good there, guy. All right. We've now sketched the graph. Let's analyze this graph. Now they're going to ask you for which values of x is it increasing. So let's take that out. Let's take that out. Let's take that. Oh, the whole part came out there. Okay, let's just draw that part again. Let's go from here. Yay. What are you doing? Right, that's out. Let's take another part out here. Let's take that out and that out there as well. Right. For which values of x is the graph? So now they're going to ask you in the exam, for which values of x? So here goes. These are your theory questions on the graph. Right. For which value or values of x is f of x increasing? For which values of x is f of x decreasing? For which values of x is the graph concave up? And where is it concave down? And these are all 1 mark questions, right? But you got to know it because every mark counts. Every mark. If a question is out of 3 marks and you lost 1 mark, you've lost a third of the question. That means you only got 60% of the question. Okay, if the question is out of 6 marks and you lost 2 marks out of 6, don't say at least I got 4. So does that mean at least you got 60%? You lost 40% of the question just because you didn't answer 2 marks. So every mark counts. Every mark counts. Let's take that out, that out, that out, and that out. Let's go to all of this. Let's take all of this. Right, answer these questions while I'm erasing the board. Answer those questions while we are erasing the board. Let's see. Where is it? Now, whenever, I want you to remember something. Come and help you along. Come and help you. Whenever you're looking at increasing and decreasing, you look at the original graph. So let's go. So let's put a small rule here. Whenever you're looking at increasing or decreasing, you look at the original graph. Whenever you're looking at concave up or concave down, you look at your point of inflection. Whenever you see the word concave up, concave down, you look at your point of inflection. It's a rule, right? So increasing, where is this graph increasing? For which values? We're answering the first one here, right? For which values of x is f of x increasing? So here, it's increasing here. It's going up, up till that point there. Now what's the x? Remember they say for which value of x? So from minus infinity, so for increasing, it's from negative infinity up to minus 5/3. That's where it's increasing. Now you can't put a square bracket there. You can say for x less than minus 5/3, no problem. If you wanted to say x less than minus 5/3, no problem. Both of them are correct, right? Then it goes decreasing, 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 then it stops, then it goes increasing again. So it's increasing there up till minus 5/3. It's increasing again from 1 to positive infinity. That's where it's increasing. And that's 1 mark or 2 marks in your paper. Where is it decreasing? Obviously it's decreasing here. Between which 2 values of x? Yes, you are right. I know you're taking down. It's between minus 5/3 and 1. That's where the graph is decreasing. Or you can say x less than 1 if you wanted to here. You could have said x less than 1 but greater than minus 5/3. You could have said that one, or you don't need to give both. Just different notation. That is in what we call interval notation, and this is what we call inequality form. Okay. Where is it concave down? Let's see, where is it concave up? So concave up, we're looking at our point of inflection. And you can see that it's concave up. If you want to look at your original graph, no problem. You can look at your original graph. Here you go. From this point, concave up. From this x value, you can see concave up. So from minus 1/3 to positive infinity, minus 1/3 to positive infinity. That's where it's concave up. Where is it concave down? You can see concave up. Smiling face, happy face. Concave down from there right up till that point there. So from negative infinity right up to minus 1/3. And that's where it is. Another way of determining concave up and concave down. This is one way. This is method 1 of determining by looking at the graph. The next one is by looking at your point of inflection. Let me just show it to you here. Let me show you something nice here. You know that your derivative your derivative was a parabola. Remember, your derivative was a parabola, and then we got minus 5 over 3 there, minus 5 over 3, and we got 1 over 2 x-intercepts of our derivative. We know that point, the turning point of my derivative, this is f dash x, that's your derivative graph. The turning point, the x value of this is your point of inflection, which is how much? Negative a third. Right, so here we go. You can clearly see here, concave down, concave up. Let's change the color. Let's change the color. Let me just show it to you. You can clearly see concave down, and then from this point going up, that's concave up. So where is it concave down? From negative infinity up to a third. There's it. From negative infinity up to a third. So we don't think we're right. We know we're right. And where is it concave up? From minus a third to positive infinity. From minus a third to positive infinity. That's just another way of you determining where is your graph concave up. So this is your point of concavity, your point of acceleration. Second derivative is acceleration. Remember, those of you doing physics, ms to the minus 2. So another word for derivative or first derivative, I don't know if you know this. I don't know if you know this, but let me tell it to you now. So now we got this, right? Another word for derivative. Another word for first derivative. Right? First derivative. You know f dash x, and you know in physics you got ms to the minus 1. Didn't we subtract for first derivative, we minus 1 from the power? Yes or no? So obviously ms to the minus 1. So what is another word for... Yes, you're saying it correct. It is speed. And another word for speed... Aha, those of you who are doing physics. Speed or velocity. First derivative. So hence second derivative. Second derivative is what we call our point of inflection or our point of concavity. And what does that refer to? That from physics you know is ms to the minus 2, second derivative. That's why we're subtracting 2. And another word for that is, yes, you are right, acceleration. So acceleration is second derivative. Speed or velocity is first derivative, and we're going to be using this when we do our speed and velocity optimization in our next episode. Right, today we're just finishing up on the cubic function. Our next episode will be dealing with optimization and calculus application in real life. So you have to stay tuned for that. So even those of you who don't know anything about calculus, if you want to know where is this used in real life, building a tower, building a house, whatever, a glass, a cup. Even if you got a cup, you want to calculate the volume total surface area of this cup using calculus. That's what we're going to be doing in our next show. Okay, so stay tuned. Shoo, I talk a lot. I'm giving myself a headache here in studio. Right, can I erase? Right, how's our cameraman and control room doing? We all okay? How much time we got left? We got 7 minutes left. MashaAllah. Right, so let's go. Now we're doing the reverse. Now we're doing the reverse. Now they give you a graph. They tell you that's minus 1. They tell you that's 2. They tell you that's 3. That's graph F. They tell you that f of x, so let's put it here on the side. They tell you that f of x is equal to x cubed plus ax squared plus bx plus c. Find a, b, c. They might even tell you, now we're finding the equation, they might even say, show that A equals something, B equals something, C equals something. And not only will they say A, B, C, right? They might even change it to A, P, Q. It's the same thing, guys. It's the same thing. Basically, what do they want? Find the equation. Okay, where do we begin? Now there are different forms, guys. There are different forms of graphs, and hopefully I don't think I'll finish everything in the 7 minutes. We might do 1 or 2 now. In our next episode we will continue. Okay, so stay tuned. DSTV channel 347. Keep it locked on. Right. Now, what's given? Firstly, this is the question in the exam. In your answer, you got to decide what's given. So 3x intercepts are given and no other point. So this is type 1. What is this? Type 1 that you might see in the exam. When 3x intercepts are given. So when 3 x-intercepts are given, we go straight. We can, remember the A can be here, the A can be there. Be careful, where is your A? Be careful, where is your A? So if A is here in the front, if A is there, it means there's another point on the graph given. We need to find A. But here, no other point is given. So we go straight into our formula. Y equals x minus x1, x minus x2, like a parabola, if 2 x-intercepts are given. And there's a third one, x minus x3. And all we do now is we substitute. We can call this one x1, we can call that x2, we can call that x3. We plug it in here and we expand it. So here goes y equals x minus minus 1 plus 1. X minus 2. X minus 3. Now let's remove the brackets. This is algebra. X plus 1. How do we remove the brackets here? How do we remove the brackets? First times we're going to FOIL it out. So here we go. X times x is x squared minus 3x minus 2x plus 6. Collect your like terms. Y is equal to x plus 1, x squared minus 3 minus 2 minus 5x plus 6. Now how do we remove the brackets here? How do we remove the brackets here? This is grade 10 work. Right? You take your first term in your first bracket, you multiply it by all, and you take your second term, you multiply it by all, and you collect your like terms. So y is equal to, let's go. Right, x times x squared, x cubed, x times minus 5x squared, x times 6 plus 6x. So we're done with the x. Now let's do 1. 1 times x squared is plus 1x squared. 1 times minus 5x, minus 5x. 1 times 6 is 6. And here we go, our final answer, f of x, which is y, is equal to x cubed. Collect your like terms. Minus 5x squared plus 1x squared minus 4x squared plus 6x minus 5x is plus 1x plus 6. And there we go. A, B, C, A, P, Q. So what is A? A is equal to minus 4. B is equal to 1, your coefficient of x, there's it, your coefficient of x is 1. And what's your C? 6, or your Q. So this could be P or B, this could be Q or C, and that is equal to 6. So minus 4, 1, and 6, taken from here. Alright, I hope you took this one down. This is type number 1. When 3 x-intercepts are given, this formula is not given on your formula sheet, so you got to know it, right? So we got to know it. Let's see. Let's go here. Let's go there. And where do we begin? We begin with that formula. X minus x1. In the next one we're going to give you another point, and then we're going to have to put an A here in the front in order for us to find the A. Right, ladies and gentlemen, boys and girls, brothers and sisters, friends and family. Hope you guys have enjoyed today's exciting show. We've done so much in calculus, so much more to go. If you ask me, how far are we in 6 episodes as far as the content for grade 12 goes? Guys, we are about 30%. 30 to 35%. We still got 65% of mathematics to go. I hope you keep yourself tuned in to channel 347 DSTV, Hilaal TV, to the Qurtuba Online Show. I'm your host, I'm your presenter, Mohammed Kota from the QOA Institute. From me and the studio and everybody here, Assalamu alaikum wa rahmatullahi wa barakatuh.
في ساحة للعلم كنا نلتقي والحب والإخلاص زاد قلوبنا نمضي إلى نور اليقين ونرتقي قمم الفلاح وتاجنا أخلاق